Suppose I wanted to calculate the potential energy stored in a system of Earth and rock far away at P. In general, it could be any planet, but let's stick to our home. Here's how I do it. I first choose a zero potential point. Usually it's my choice, but here we take zero to be far away. In physics, we call that as infinity, but I'll just call that as far away. So take far away as a zero potential. Next, I calculate the amount of work that I got to do in pushing the rock all the way from infinity to point P. Notice that my push has to be in the opposite direction of the motion, hinting you that my work done would be negative. That is not uncommon at all, because as I move this book down, I am actually pushing it upwards while lowering it down, doing negative work, so it's the same thing, right? But the problem is, unlike this book, when I start out, the rock is far away, gravity is weaker, and so I have to push a little. But as I come closer to P, gravity gets stronger, and so I have to push now harder. So to calculate the work done, we have to deal with changing forces, and that calls for integrals. To set up the integral, we choose a random point between far away and P. Let's call this point as D. Take this direction to be positive. Write down the forces. Gravity is pulling it with force of gravity. And I am pushing it away with equal and opposite force of Massey. Next, we imagine that my force gives a teeny weeny beany displacement dx. It is so teeny that the forces over the displacement virtually remain the same. But you may think that dx must have been this way. But since it is so tiny, I actually have the liberty to put it any ways I want, and I choose the positive direction, making the integral super easy. Now, the tiny work that Massey has done in taking that stone through dx is the force of Massey dot dx. The force of Massey is positive, dx is positive, and the angle is 0, making cos 0 1. Now the total work by Massey would be the integral in going from far away to point P. And this integral is easy peasy, yielding minus gmm by r. And you wouldn't be surprised because it is negative. And with this result, we can play around, do some cool stuff, which we shall see next time. So now you know how I do it. Physics rocks.